All right, let's get started learning about minerals today. So what is a mineral? Its definition is it's a naturally occurring pure chemical substance. And there's over 4,000 that we've found here on Earth. There's 5 overall characteristics that you have to know that define a mineral. They are naturally occurring, solid, inorganic, they have a specific and fixed chemical makeup, and they have orderly crystalline structures. So what do all of these mean? Let's get into them in a little bit more detail here. So by naturally occurring, we mean it has to be formed by natural processes. It can't be something that we made in a lab. It can't be man-made. The second point says they have to be solids. This means no liquids, no gases. They can only be the hard, solid state of matter. The third is inorganic. So this isn't like the organic that we talk about when you go to the grocery store. It means that they're not made by living things like wood or pearls. Sorry, there was a little typo there. It should be an L. Pearls. Now, some what we would call rocks or what seem to be minerals are actually living things like fossils or shells. These are all made by living organisms, so we can't consider them as minerals. They have to be something that's not made by a living thing. The fourth point says they have a specific and fixed chemical makeup. So what this means is that all minerals have a very specific characteristic. They're made of a very specific material, whether it's an element or a certain combination of elements. But it makes them different from all other minerals out there. They're unique. And the last one is they all have an orderly crystalline structure. So the atoms inside these minerals, they are arranged in a way that they make a repeated pattern that we call a crystal. So how do minerals form? Well, there's 2 real ways that it happens, but overall, they form through a process that we call crystallization. It's how they make that crystal structure for their atoms. And the 2 ways include the crystallization of magma or lava, or of materials that were dissolved in water. So crystallization through magma and lava is the first one that we're going to talk about. So this is one way we make a mineral. The magma is melted rock that's found deep in the earth. Often it comes from the mantle. And sometimes, though, this magma can break through the crust, and when it does and it flows onto the earth, we call it lava. So 2 ways that this happens. The lava, once it's broken through the crust, can then cool on the surface of the earth. Now, lava cools pretty quickly, so any minerals that you make this way are often pretty small. Another way is that as the magma moves up in the mantle, so away from the core and towards the crust, it'll start to cool down because it gets colder and colder the further you go towards the crust. And eventually it'll harden and crystallize to form structures. And this happens so slowly that often these crystals can grow very large. And here's an example of that.
That is unbelievable. This is just mad. Absolutely gorgeous, isn't it?
This is La Cueva de los Cristales. For my money, the most spectacular cave of crystals discovered anywhere in the world.
You know, I've travelled around the world to see some of the most amazing geology, but this place just tops it all. I look at it. It really looks perfect. You can see through them, it's so translucent. And they're different types. You can see these ones that are like roses building up, and then these columns, these pillars. Absolutely magnificent.
All right, so that was pretty cool. Basically, all of those were gigantic minerals that had crystallized underground. That's a cave down in Mexico. And because it was cooling so slowly, these crystals were able to be huge in size. Now it's very hot and the air is very toxic down there, so you can't spend a lot of time down there, and it's not really for tourists, it's just for scientists at this point. But it's still pretty cool that we get to take a peek at that. Now, the second way that we can form a mineral, a mineral, sorry, I was reading material on the slide here. So we can do crystallization of dissolved materials. So remember from our last lecture that ions can be dissolved in water. And ions are just atoms that have gained or lost electrons. Now, as the water evaporates, or if these ions and materials inside the water get separated from the water, they can dry out and start to crystallize. So often you'll find these types of minerals near or in bodies of water, or even underground where water flows. So what are the properties of a mineral though? So we've talked about how they're formed, we've talked about what it is, but what are their properties? How can we define and differentiate or tell the difference between minerals? So we use these properties: luster, hardness, color, streak, magnetism, cleavage and fracture, and reaction to acid. So let's go through all of these one by one. So the first is luster. This is how the light will reflect off the surface of the mineral. So there's metallic and non-metallic luster. If you look at the pictures on the right, the one on the bottom is an example of metallic luster. It looks like a metal. It's shiny the way you would think of a metal. But this one up here, it looks more like a traditional crystal or gem that we would think of. And it doesn't look like a metal, but it's still shiny in its own way. It's how the light reflects off the surface. Another property of a mineral is its color. What is the unique color to the mineral? Now, oftentimes this is deceptive because color can change in the presence of oxygen, because over time it can kind of have other materials covering the color so you can't see it true. So there's another way that we'll actually be able to tell the true color of the mineral. Hardness is our next one. So this is the ability of a material to resist being scratched. So how hard is it? Can it get scratched by something else? Something like diamond, which is the hardest substance, can't be scratched by anything else, any other mineral at least. And the softest mineral in the world is what we call talc. It has what we call a Mohs hardness scale of 1. It is the very lowest. The highest on this scale of hardness is 10.10, which is diamond. And you can see on the right here, there's images of different minerals and common objects that compare. So you can use different household objects to see how hard a mineral is. For example, you can see that your fingernail has a hardness on this scale of about 2.5, which is a lot higher than gypsum and talc. So if you can take a rock and scratch it, it's probably one of these two. Now, this one is how we can really tell the color of a mineral. Streak is the color when it's in its powdered form. So you can see the image on the right. These rocks all fairly look the same color, but when we streak them, we can see their actual color come through, their powdered color. So you test this by taking your mineral and rubbing it on a piece of porcelain. Now, porcelain has a hardness of 7, so all of your minerals have to be harder than, must be greater, harder than a Mohs scale of 7, or they won't leave this streak behind, they won't leave this coloring behind. So anything that's lower isn't exactly good for this type of a test. The next one is cleavage and fracture. This is how the mineral will break, what type of pattern it forms when it breaks. The first one, cleavage, is the tendency of the mineral to break along a line or a plane. So this looks very geometric. There's always a repeated structure or pattern. So these images and these ones here are all breaking along a plane. So they have what we call cleavage. Now, fracture is the tendency of a mineral to break along curved surfaces or without a set shape. So it looks kind of jagged or irregular or just not smooth and geometric like the other ones. So that would be this mineral here in the center of the screen. Some minerals can be magnetic, or they'll have iron in them that attracts or repels magnets. Now, iron is the main magnetic element. So usually when we're talking about a mineral having this quality, they have to have iron in them. And the last one is reaction to acid. So acids are very corrosive. It means they can eat away at things. So some acids have the ability to dissolve certain minerals. So what kinds of minerals can be dissolved by acids? Well, any that have what we call carbonate in them. And it'll start to form bubbles of carbon dioxide if this acid comes in contact with the carbonate inside the mineral. The last thing I want to mention is two groups of minerals that you may have heard of before. These two are known because they give us monetary or economic value. They're worth something to us. The first one is ores. This is where we tend to find a lot of our metals. We find ores or mixtures of the metal with other minerals, and we can then extract that metal from the ore and sell it. Another one is gemstones. These have value because 1, they're incredibly rare, and 2, they're incredibly pretty. So that's all I have for our minerals PowerPoint. If you guys want to go back and make sure you got all the vocab, I'd recommend you do that because remember, the vocab is an essential part of this. So make sure you have that all done, and I will see you next class.